Let's talk about section 1.4, the matrix equation, AX equals B. I'm going to break this lecture into three separate parts, three videos. The first part will be about how we multiply a matrix times a column vector. The second part, the second video will discuss the matrix equation, AX equals B. And in the third video, we'll have a little bit of theory. So let's go ahead and get started on the first video here. Let A denote an m by n matrix having n columns. And we'll denote those n column vectors as A1, A2 to AN. Let X denote a column vector having n entries as written, x1, x2 to xn. Notice that the number of columns of the matrix matches the number of entries of the vector x. We define the product of A times x to be the linear combination of the columns of A using the entries of x as weights. So let's talk about what this means. That's quite a mouthful. A times x is going to equal, well, I'll write the matrix A in terms of its columns. So column A1, column A2 through column AN times the vector x I write as x1, x2, dot, 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 xn. What we're going to do is we're going to take each entry of x times the corresponding column of A. So I'll take x1 times A1 and add to that x2, the second entry of x, times A2, the second column of A, and go all the way down the line to the last entry of x times the last column of A. In order to carry out this calculation, the number of columns of A must equal the number of entries of x. In our beginning portion of this, note that's really the n columns matching the n entries. And I think I also wanted to make an observation here that x is in Rn, since we started using that Rn notation. Now, in order to bring this to life a little bit, let's go ahead and do an example. And you're going to see this is not really that difficult of a operation once you get used to it. So let's go ahead and do a calculation here. So we're going to do an exercise, find the product of a matrix with entries as given. This is actually a 2 by 4 matrix. And we're going to multiply by, here's my x column vector. It's a 4 by 1 column vector with 4 entries. So the way we multiply, what we're going to do is we're going to take each column of A. So maybe I'll just mark these columns. You don't normally have to mark the columns in red like this. And they're going to be multiplied by each of the 4 entries of x. So I'm just going to circle those separately to suggest what we're going to do here. So my product is going to be, well, I take the first entry of the column vector, 3, times the first column of my matrix, 2, 1. And I'm going to add to that the second entry of x. I can just write minus 1 times the second column of the matrix, negative 1, negative 3. Then I add the third entry of x, so 4 times the third column of the matrix, 0, 5, plus the, now I'm to the last entry, the fourth entry of x, times the fourth column, negative 2, 0, of the matrix. Now, next step is to go ahead and multiply these scalars times the individual column vectors. So 3 times 2, 1 is going to be 6, 3. Negative 1 times the column vector negative 1, negative 3, that will be plus, I'll have positive 1, positive 3, plus 4 times 0 is 0, 4 times 5 is 20, so 0, 20, plus, now when I multiply 0 times negative 2, I get 0, 0 times 0 is 0, so I have the column vector 0, 0 on the end. And now finally, to get my final answer here, I'm going to add these 4 column vectors, or these together. So I add the entries. 6 plus 1 plus 0 plus 0 is 7. 3 plus 3 plus 20 plus 0 is 26. So this column vector, 726, is the product. Notice my answer here is actually a 2 by 1 column vector. That's the answer to the multiplication problem. I started out with a 2 by 4 matrix that I multiplied by a 4 by 1 column vector, and I ended up with a 2 by 1 column vector. So the dimensions change here. Now we're going to move on to the second video where we apply this idea of multiplying a matrix times a column vector. That will be in part 2.